Hello everyone, welcome back. So this is the fourth question of the contest 465. So we have already uploaded Q1, Q2 and Q3. Please go and watch if you are not tried. Okay. So let's understand the next question that we have. Sum of beautiful subsequences. You know what is the subsequences, right? So as it is saying that a subsequence is a non-empty array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So we have to do the sum of beautiful subsequences. So you know the subsequences. Now understand beautiful. The question is saying that we have given integer array. Let's call nums. We have given 1, 2, 3, and for every positive integer z, we define the beauty of z as the product of z and the number of a strictly increasing subsequence of nums whose greatest common divisor is exactly z. And we have to return the sum of beauty values of all the positive integers z, and we have to take the modulo if the value is coming larger. Let's understand the example here. So in the example one, we have given nums is 1 to 3 and the output is coming 10 because it is saying all strictly increasing subsequences. For 1 to 3 is nothing but what? Subsequences 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3, right? Like that we have. If you know the GCD, if you find the GCD, you will get 1, 2, 3, 1, 1, 1, 1, like that. Okay. And if you calculate the beauty of each GCD, so you have to understand that. So as we know, GCD is 5. And GCD we will take, how we are going to find the beauty of for each GCD is nothing but what? GCD into count. Count is what? The count of subsequences. So we know that when GCD is 1, how many counts we got? So if you go for all the table above, you will find for 1, for 1, 2, for 1, 3, for 2, 3, for 1, 2, 3, with GCD 1 is 5, means count is 5. You just need to multiply it, you will get the beauty. Beauties become what? 5. Like that you will calculate all the beauties and you will do sum, you will get the values 10. I hope you understand, right? So can we say we have given nums, we have given, right? And we have to consider every non strictly increasing subsequence, that is order is preserved, right? So each next value is strictly greater than the previous one, and for each subsequences we have to compute g is equal to GCD of all the elements that we have seen, right? And the beauty computed by the sequences of z, right? By the sequences of z, right? And the problem is asking the sum of beauties of all strictly increasing sequence, and if it is coming greater value, we have to also take modulo, right? So we can say we have to group all the increasing subsequences by their GCDs, and we'll count the GCD beauty, we can say, and when a value we have find the sum, means we can say sum z is equal to nothing but the z into count of z, and we have to take the mod, right? Let me tell you how. So let's understand what I'm trying to say. As we know, very first we have to group the increasing subsequences by their GCD, right? So we can increase that, right? And can we say this GCD is coming in nothing but z. So if we count the GCD, so we'll say count of z, we can say count of z, right? And this count of z is the number of sequences whose GCD is 1, or GCD is z, right? GCD is z, we can say. So we'll say answer is nothing but their sum, means the beauty. And for that, we'll say answer is nothing but we have to take the sum of z, we can say, and we'll say z into their GCD, z into the count, right? We can say count of z, right? And we have to take the mod. Can we say that? We have to take the mod with the m that we have given. This is what we need to do. So let's understand the intuition how to implement the code. Very first, we know that the mod we have given is 10 to the power 9 plus 7, right? So that we have to consider in the very first step. Okay, then we'll create a DP because we have to use the DP array. Let's call this as a has map, right, of length n. and will iterate over I from 0 to n, and for dp at I we'll put them on the map, let's call nums at I. Okay, and this is nothing but dp at I, we can say, and we'll use the get or default, and we'll increase the single elements. When we find it's already there, we'll increase the with the +1. When you use the get method, right, we'll use the get, we'll pass get default like that, and we'll do the +1, right, like we will do for all the elements. Then we'll go for all the j will go from where, 0 to I minus 1 will go, and we'll check if nums at j is less than nums at I, right. For each we'll find the g and the count, right, in dp at j. How we are going to find the new z? To find the new z, you have to take the gcd z and the nums at I. Then we'll find dp at I and the new z, we can say. Okay, and then we'll take the count, and then we have to take the modulo, right, and after that we'll keep adding all those in the answer. We'll repeat this until dp at I is not ready, and then we'll add into the answer and we'll return the answer. Okay, so I'll put the code into the comment box, because I think only some minute is left, because my internet is also slow. So I'll try to create another video in the deep dive session. Okay, thank you guys, thank you for watching this video. I'll put the code into the comment box, please get from there.